Good afternoon, everybody. Welcome to class today. Thank you for joining me, whether you are watching live or you're watching the recording a little bit later on. I appreciate you watching. So this week we're talking about how the internet works, and we're just going to kind of scratch the surface with that. But by the time we're done with our conversation today, you should have a good understanding of what you would need to know to be able to complete your module lab for this module. Before we get into this topic, let's do just a handful of announcements here as we're getting going. Don't forget we have our weekly study hall, which is from 10:30 a.m. to 3:30 p.m. on Thursdays in Paxoy room 3200. I'll be, in person there in the room in case you want to stop by. I'll also be monitoring Teams during that time. In case you want to contact me on Teams during that time, just for questions, for individual help, for, just to have some time to work on stuff in the room. Everything there works for me. And that's in addition to all of the regular student hours that are listed in the module or in the course. So we're on to Module 2, which is about how the internet works. It's sort of just it's sort of an overview primer of just how all this works. And, we talk about this for a reason. And really it's several reasons, right, that we talk about this kind of stuff. One, it's just good for us to have a baseline understanding of kind of what's going on behind the scenes when these things are occurring. And another thing is that a big deal out of all this is basically how the request and response happens in terms of, actually sending us the files from a server for a website. Right? That's an enormous deal that we're dealing with there. So we're going to talk about these things today. The first thing that I want to look at as we're talking about how the internet works is kind of the hardware surrounding the internet. Again, we're just going to kind of look at this from a really high overview, right? We'll save the in-depth networking details for your CTI 120 class. And we'll just kind of look at this from a high overview perspective with a focus on specifically website traffic and how that moves through. So the first thing that we're going to need to talk about is we're going to need to talk about the key piece of hardware that is utilized for our web traffic, and that is the server. So since we're thinking about the internet in general, we need to think about the server. The server is the big thing here. So we have our server hardware with server software, and that gives us a server. So what exactly is a server, right? There are, we kind of maybe have this conception in our brains of what a server is. Maybe we think of the idea of a server. Maybe we think of the term cloud. Right, but at the end of the day, all a server is just a glorified computer, right? It's just somebody else's computer that they're running. And the cloud is just servers where you're storing your data, right? That you're accessing it through the internet. So the server is just somebody else's computer. The cloud is just a bunch of servers. So the cloud is just a bunch of other people's computers. And so the server is the part of our structure in terms of the internet that serves the content. Right? When we start talking about how exactly these files are transferred across the internet in a bit, we will examine the concept of serving something up, right? We'll look at how something gets served up, how a copy of it is made on the server and sent to you as the user on your end, because that's really what's happening there, right? We're not seeing, when we see a website, we're not seeing files on a server. We're seeing files that were sent to a server, that were served to us by a server. So you can almost think of it as, like you're in a restaurant and you're dealing with the server at a restaurant, right? You order your food, you say, hey, I want this. They go back to the kitchen and they say, oh, give me an order of this. It gets processed, it gets cooked up, it gets brought back out to you. And you have the food there at the table that you can eat. Right? So, our server and our internet process here kind of behaves in the exact same way as that. So we can kind of use that as an analogy as we approach these topics today. But there are three primary types of servers that we look at: a desktop server, a rack server, and a blade server. And just really briefly here, we can kind of talk about these different types of servers. First of all is the desktop server. Another term for a desktop server is also a tower server. These are very small server devices, right? They look very similar to desktop PCs. They're basically a desktop PC, but a little bit bigger, right? What makes it different from our standard computer server is just the fact that it has a little bit more room for storage expansion, right? So when we think about space for storage in here, it has a little bit more room for hard drives and such, right? We can actually use just a basic server or a basic desktop computer, or really any computer, as a server if we wanted to. Right, one of the things that we did when I first started working here, I was in another department at the time, and a colleague of mine and we had a project that we needed to make accessible over the internet. And we were using a particular tech stack in order to be able to do it. We'll talk about what stacks are in just a few minutes, but a tech stack is just the software that's running on your server that is allowing the server to operate. So we had a particular tech stack that we were using, a particular grouping of software that we were using to serve up some information, and that was not supported by any of the other servers on campus. And well, we finally decided, we want to use this to be able to do this. We don't really need this to be available for long. So let's just get a desktop computer. Let's install some kind of server operating system on it. And let's configure it to operate as a server. And that's exactly what we did. And by the time period that was up and we didn't need that server anymore, it had seen much better days, right? It had been through, it had been used really, really hard. I'm not sure that computer had much of a life after operating as a server for that period of time. But it was useful and it worked during the times it was used. So we can definitely use a regular computer as a server. Ideally, we'd want something that would be a little bit more powerful, a little bit more, storage space, a little bit more RAM and processing power. Right, and so these big desktop servers would accommodate us for that. Now, when you get into production, you're not really using desktop servers, right? Because as you can imagine, if we had, one of these big sort of desktop-based servers for, every sort of server redundancy we need, this would take up so much space, right? The footprint would be absolutely enormous. Everything would have to be, kind of laid out side by side, because these are computer towers. You can't really stack them, or else you're going to be, limiting airflow and things like that. So they're not really conducive for a big, major production environment. Right? These are kinds of things that are for, a use case like I described there, where we used our desktop computer for that. right? If we just have one thing we need to serve ourselves, maybe a handful of things, just some very small needs, we'd use a desktop server. If we were going to a big environment like a data center, for example, we'd use rack or even blade servers. Right, so if you go up to the data center here at Cleveland Community College, what you will primarily see are rack servers. And rack servers are designed to be able to stack multiple of them in a rack. So you might have seen these sorts of racks before. They're about roughly 8 feet tall, I think. You can open them up. They have these rails going down the side of them where you can screw different devices into anything that really is rack mountable. Right? When we hear it said that something is rack mountable, it means it's able to be basically screwed into a rack. And so these rack servers are rack mountable. They're servers that are able to be screwed into a rack, and they are built in such a way that form factor can accommodate everything that it needs. Right? So instead of just one of these rack servers, or instead of just one of our desktop server just sitting in its one location, we can take 8 to 10 or more rack servers, put them in a rack, and have the power and networking, power and data cables run throughout the rack for all of the servers. So we're able to fit many more servers into a much smaller space. Now, cooling is difficult for these, right? Like if we go up into the data center here at the college, which many of you all will do at some point, you'll notice that we kind of have set up what we call hot aisle, cold aisle, right? Underneath the floor in the data center is a big open air plenum area where our HVAC units are pushing cold air. They get pushed up through the grates in the floor, blow over the front of the servers, and are exhausted out of the back as hot air, which we just use the fact that hot air rises to be able to take the hot air out of the ceiling and vent it out. Right? That's the way that works more or less. So we're able to get this airflow over the front of our servers, over the tops and through our servers, and then exhaust it out the back, into the ceiling, and out. Right, so, these devices, even though they're stacked on top of one another, it gives us some cooling challenges, but if we have some, big computer room air conditioners and we have the right infrastructure and everything in place, they're easier to cool. Right, but the scalability is the big thing out of these. Right, the fact that we can take multiple of them, put them in one area, add to them as we need them, is a big deal here. We can also look at blade servers here. Blade servers are very similar to rack servers in design. However, they are much thinner. And since they are thinner, they cost a lot more. Right, so what makes kind of our blade server different is that when we look at our rack server here, this is one server. Right, this is one server with a bunch of bays for hard drives in it. When we look at our blade server here, we have multiple servers inside of a blade chassis. So basically each of these devices that you kind of see inserted here into this device is its own server, and each row is its own thing here, right? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, about 14 or so servers in here, just counting them quickly. Right, each one of these rows, if we were to look at them up and down here, and I'll mark it up here for us. is a server. So it just gets inserted and can be pulled out as need be. So we can see they're quite a bit thinner than those other servers, right, that we were just looking at. And we fit multiple of them in a chassis. But because of this form factor, because of the smallness of the technology, right, it's a lot more expensive. So we don't see these as much in specific enterprise applications. You know, if you're using a big enterprise application for a company that makes a lot of money, they might have blade servers. You know, because the blades can be traded out easier, they can be dealt with a little bit easier. They're a little bit smaller form factor, so we can fit even more of them into a particular area. They just give us the ability to work with them. But at the end of the day, right, the big thing to kind of get out of this is that, you know, a server is a server is a server, right? We have different types of servers that look different, but they're all basically doing the same thing. And so that's half of what it takes to have a server. Right? Having the hardware that's capable of, you know, meeting the needs of anybody who needs anything sort of transferred along the network or the internet. We need a server for that. But we also need software to be able to manage everything that's on the server. And that's where the idea of server stacks comes in. Right? So server software varies based on the applications that are hosted on a particular system. When we're typically looking at server software, we're going to look at some kind of operating system, some kind of HTTP server software that is facilitating data transfer from the user to the server and then back again, some sort of database software, and then a programming language interpreter. Right? And if we look here, we have a kind of a visual representation of a presumed what we call LAMP server, LAMP. And we typically refer to our server stacks by some sort of acronym, right? In this case, it's LAMP. Our something AMP server. Most of the time, we might even refer to this as something called an X AMP server stack. Because most of the software is the same, just we kind of change the operating system. Right? So in this instance, we have Linux. Linux is the operating system that's in this depiction of a stack here. That's where the L comes from in LAMP. When it comes to what an operating system does, your operating system just makes sure that all of your hardware on your machines work together. Right? That you're able to send and receive information from the processor to the RAM to the hard drives, and everything's just kind of working together, right? That's what our operating system does. And so our operating system could be any version of, you know, a server-compatible operating system that exists. Linux is the most common because it's free and open source, right? So somebody might use an Ubuntu server OS to create a Linux server, or any number of Linux distributions that are available out there to create a Linux server. But this could also be Windows, right? Windows is an operating system. Or Mac. Mac is an operating system. Right? So if you're using Windows or Mac, we would just replace the L in LAMP with a W or an M and say you were using a WAMP or a MAMP. Which is why we typically will just simplify that and go XAMP. So we have some kind of operating system, whether it's Linux, Windows, or Mac, and then we have our HTTP transfer software, which in this case is Apache. Apache is handling our data transferring in a LAMP stack. So it's making sure things are communicating across the network properly, that we're sending and receiving data that's proper, that packets are moving in and out the way that they should be. It handles permissions. It handles all sorts of things in this sort of stack. And the next one is our database language. In this case, it's MySQL. Right? That's the M in our LAMP stack. So Linux is our L, Apache is our A, MySQL is our M. And our database software is just software that holds data, right? We have a database course in our programming and web development track where we look at MySQL in a little bit more depth. Right, and some of the big things that we examine out of MySQL are basically how we can manipulate data that's in our tables, how we can process data and turn it into information, which is valuable, and how we can keep and store data for the long term. So data is something that's incredibly valuable. Data is a part of every single web application that exists. So we need some sort of data management software on our servers to be able to help us out. And finally, we have the P in our LAMP stack, which is either PHP, Perl, or Python in these instances. Right? It's basically any programming language interpreter, anything that needs to be interpreted by the server and sent to us. Right? And one of the things that we talk about in development is that we have front-end languages and we have back-end languages. Right? And so our language interpreter is for our back-end languages. Right? If we were to kind of divide these out, right? We said we had a front-end language and we have our back-end languages. These two things look quite different. Right? And so on our front end, these are things that are rendered by our browser. So these are things that are rendered by our browser. These are the things that our browser knows how to deal with. Our languages of choice here are HTML, CSS, and JavaScript. So our browser knows how to understand our HTML, our CSS, and our JavaScript. So when it gets sent HTML, CSS, and JavaScript files from the server, it knows how to read them and interpret them and make them into something that we can see and read. Right? Conversely, on the back end, these are things that need to be processed by our server. Right? So we need some sort of interpretation to happen to them. And these are going to be languages like Kotlin, which is Java for the web, or PHP. Or, maybe something like Ruby. Or even, what gets it a little bit confusing, JavaScript. Right? JavaScript can be both a front-end and a back-end language. But with our back-end languages, there needs to be some other kind of process done to our code before we can send it out. Our browser, by default, doesn't know Java. It doesn't know PHP. It doesn't know Ruby. It doesn't know Python, right? There are several different Python libraries for the web, like Django, which is a way that we can use Python on the web. Our browser doesn't know these languages, right? So we have to have a server, an interpreter installed on our server that does know these languages, that can take these languages and convert them into something that my browser does know, i.e. our front-end languages. HTML, CSS, and JavaScript. And so JavaScript are in both categories because there are different types of JavaScript, right? Our front-end JavaScript is what we consider as like vanilla JavaScript. But when we bring it into a framework or we're dealing with it on a Node.js server stack, which we'll look at in just a moment, then there needs to be some sort of interpretation done with it before it becomes just regular old JavaScript, because we're dealing with other things having to do with it, right? Like a big thing in, for example, React, which is a web framework, is that it uses a virtual DOM as opposed to a regular DOM. Right, we'll talk more about the DOM when we get to HTML. But the fact that it has this thing virtualized instead of just using the regular one that's provided by the browser means that you have to do a little bit of interpretation before sending it forward. So that's the kind of thing that we're looking at here. Right, so when we're looking at front end versus back end, it's about what is needed to be able to understand that code. Your front end code's all understood by your browser. Your back-end code has to be interpreted by the server and converted into something that the browser can understand. So we can see another example of these sorts of stacks here. Right, on the left-hand side there, we have our LAMP stack, right? We see that again. Linux, Apache, MySQL, and PHP. On the right-hand side here, we have a mean stack. MongoDB, Express.js, AngularJS, and Node.js. And so this is going to be basically the same, right, as what we're kind of dealing with our LAMP stack. Just slightly different. So when we're looking at these different parts of our acronym, right, they don't quite measure up. Right, like we said that Linux is our operating system for our LAMP stack. In our mean stack, Node is our operating system. Right, Node kind of is the backbone of the server there. And Node is based in JavaScript, and this is server-side JavaScript or back-end JavaScript, so it has to be interpreted by an interpreter that you install on the server. Apache being what handles the HTTP communication protocols in our LAMP stack, is Express in our mean stack. Right, Express is a framework that handles HTTP call-in responses. Right, so it's Express.js. It's also written in JavaScript. So again, that's another thing that has to be interpreted on the back end by JavaScript. That's where we kind of get this idea that JavaScript is both front end and back end. The database in our LAMP stack, again, is MySQL, one of the most widely used databases in the world. In a standard mean stack, our database is MongoDB. And so our mean stack is typically a more modern, as one might consider it, tech stack. So it uses a non-relational or NoSQL database, like MongoDB, instead of the relational database, like MySQL. So there are advantages and disadvantages of using both a relational versus a non-relational database. We'll talk about some of that when we get to databases toward the end of the semester. In general, people are of the opinion that for some larger applications, a non-relational database might run a little bit faster. So it might be good for production in that sort of way. And then finally, we have a framework language that is a programming language that needs to be interpreted by the server. In our LAMP stack, we have PHP. And the corresponding piece to that in our mean stack is our AngularJS. Again, JavaScript, right? The only thing that's not really written in JavaScript in our mean stack is our MongoDB. So we can have a regular old JavaScript, a plain old JavaScript file that gets interpreted by our browser that's sent out through our LAMP stack. Or if we were looking at something like a mean stack where everything is sort of JavaScript based, then we get this idea that, you know, JavaScript can be both a front-end language and a back-end language. We start to see that a little bit more clearly here. So discussing that, let's just kind of go through the process of how this would normally work. Right, and basically what we see here is the general process. We're going to add a few more steps to it as we kind of go along the way here. But this is the general process that happens. Right, when you click on your browser and you type in a URL, what you're doing is you are making a request to a server. Right, so what we're talking about here with you is you as a client. Right, we use the term clients here to just be any user device, so anything that you own as an end user that you have connected to the internet. Right, this is your home computer, this is your phone, this is any device. We can refer to it as a client. And when you get on that device and you suggest a web page that you want to get, you know, you go on there and you enter www.clevelandcc.edu, or you go to Google and you type in a search result, you are making what we call a request. Right, so we can kind of put it in that analogy that we were looking at earlier, right? You go into a restaurant, you sit down, the server comes up to your table and you place an order. Right, you make a request. So that's the start of your journey of your device getting the website. So you make this request and it gets taken back to the kitchen. In this instance, the kitchen is more like our computer server, right? We're talking about, you know, different types of servers here. Our person server is more like HTTP in this instance, where it's the communication protocol getting things from the client back and to the kitchen and then back to the client. So maybe we shouldn't mix our metaphors there, but it is kind of a good one. All right, so the order is taken back to the kitchen, and the kitchen, which is like our computer server, says, okay, I'm going to make some of that and I'm going to send it out. Right, so the server takes and makes a copy of the web page documents and sends them back to the user. Right, so if there's any code that needs to be interpreted first, right, the server is going to interpret that. It's going to get everything in HTML, CSS, and JavaScript files, things that my browser can read, and it's going to send me a copy of those files to look at. All right, so that's something that's kind of interesting when we think about, you know, how a server works. Is the website that you're seeing when you open up a website is on your own computer. Right, you've requested a copy of it, and it sent you back a copy of it. And it's put it into your cache. We call that a cache, when you have a copy of a website in the memory of your computer. We say that site is in your cache. And that helps it load faster and work faster and all that kind of stuff. So you're not actually seeing the files on the server. You're seeing the results of getting sent a set of files back. So when you can't see a website because the server is down, it's not because you can't see what's on the server. I mean, it kind of is. Right? But it's because the server couldn't send you a response. It couldn't send you the files back. You made the request, and when it goes to make the response to send you the files back, it can't do it. Right, and so if we were to break down what's happening when you enter www.clevelandcc.edu or whatever into your browser, we could break it down into its most basic level in this sort of way. We are going to add some extra parts to it, though, but really, this is the biggest thing, right? You make a request, that request is sent to the server, that server takes the files, it makes them something that your browser can read, and sends you a copy of them. And then your browser reads those files and displays you the result. That's kind of this request and response situation that we have going on here. Now there's other stuff that we have to deal with, right? One of them is TCP/IP. TCP/IP, Transmission Control Protocol and Internet Protocol. And these are communication protocols that define how data should travel across the internet. So a subset of TCP/IP is HTTP. Right, our HTTP is a subset of communication protocols underneath TCP/IP. Right, you get a little bit deeper into about what all these do when you progress in networking courses. For our course here, our big goal is to just say, okay, we have this protocol. It's called TCP/IP, and it allows us to transfer things across the network. It allows us to send our request. It allows us to get back our response. Right, easy peasy. The next thing that we have to deal with is our DNS. Our DNS. So what's interesting about our DNS, or domain name server, is that it's kind of like an address book for websites. Most people will never say, I'm going to go to 137 South Post Road. Right, 137 South Post Road is the address of Cleveland Community College. Instead of saying, I'm going to go to this address, you're going to say, okay, I'm going to go to Cleveland Community College. Our servers, by default, have an IP address. And you might have already discussed IP addresses in CTI 120, right? We look at a set of 4 numbers that could be, 4 triplets. Could be 1 number, could be 2 numbers, could be 3 numbers. So anything from a set of 4 numbers that have between 1 and 3 digits per number, right? And that's our IP address. And so, just like the building has an address, just like Cleveland Community College has an address, which is 137 South Post Road, websites have an address. And if we look up our command prompt here, we can actually see some of this occurring. Right? If I ping www.espn.com, espn.com is our URL. It's the name of the site. So it's what gets resolved after the DNS tells us. Let me rephrase, getting a little bit late in the day. So we tell the DNS server, where is espn.com? And it replies back to us with its address. 18.160.37.61. Now, it used to be that, we could go ahead and enter this IP address in to a browser. But most of the time nowadays, if somebody's trying to access a site via an IP, you're not going to get there because of, they've got security things set up that prevent that from happening. Right, so this used to be a really interesting demonstration where I could do this ping and get the URL, get the IP address for the site, plug that into a browser, and it would actually bring up that site. But since we're more concerned with security now, that is not as easy to do. So we're telling so when we enter in www.espn.com or whatever into our browser, into the URL bar of that browser, that's kind of like telling your GPS system, I want to go to Cleveland Community College. And so your GPS system is going to respond to you with, okay, Cleveland Community College is at 137 South Post Road. Here's how you get there. Right, so the same thing here. I'm telling my DNS server, I want to go to ESPN.com. And it's telling me, okay, ESPN.com is at 18.160.37.61. Here's how you get there. So that's all well and good, right? Like that helps us out. So that's kind of another step in what it takes. So that adds another little hiccup into what we saw earlier with that request and response, right? So the first thing I'm doing is I'm saying, okay, this is the website I want to go to. Where is it located? And it says, okay, it's located at blah, 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 blah IP address. Right? And you can see why we would want to do that there, right? Like that IP address is hard to remember. 4 seemingly random numbers separated by periods. It'd be nearly impossible to remember that if you needed to use that with any consistency. But I can remember ESPN.com. Right? I can remember that domain name. But I need my servers to know what domain name's what. So we have these domain name servers that work with that. Now, security on our domain name servers is really important, right? So for those of you in cybersecurity, that's something to think about, is that security on these domain name servers is incredibly important. Because if I were to access one of these, even if I were to just access one domain name server, right? There are hundreds, thousands of them with similar information on them. If I were to just access one domain name server and institute a bit of a man-in-the-middle attack that will change which domain name is dealing with which IP address, then you can influence where people go. So I might think I'm going to ESPN.com, but if the IP address is compromised on the domain name server, it's going to say, oh yeah, ESPN.com is at this other IP address that's not actually ESPN.com. Right? Because all this DNS server basically is just an address book, right? It's got a list of names on one side and a list of addresses on the other. So if you could switch that address, instead of 137 South Post Road, you reply back to it, oh yeah, 705 East Dixon Boulevard. Your person's going to the wrong place, but they're going to be trusting that they go to the right place. And that's a very common attack if we don't secure our DNS servers. HTTP, we mentioned, right? That's our hypertext transfer protocol. That's a part of our TCP/IP internet transfer protocols. Right? For our purposes, it's the application protocol that defines the language for clients and servers to speak to one another, which is HTML. Right? So we're specifically sending HTML across HTTP. Or HTTPS. HTTPS is secure, whereas HTTP is not. Right? And the way that I like to kind of describe that between HTTP and HTTPS is I can stand across the room from somebody and I can yell at them some information. And that's basically what's happening during HTTP transfer. Right? You're just kind of yelling at the server the information that you're sending, and it's yelling back to you the information that you're getting back. Which is all well and good, right? Like it works and it gets you the information. But everybody else who's kind of listening around you can hear everything that you say. Right? Because you're just yelling it across the room. Whereas HTTPS, imagine now that you had a couple of tin cans with a string tied between them. Or a cell phone, right, for a better example. And you were able to call and talk to the other person on the side of the room using a low, quiet voice to where only you and the other person could hear one another. That's the HTTPS secure transfer. Right, that's how that works. It just kind of keeps your communication quiet. So if there's anybody listening around you, they won't hear it. They won't be able to get that information. Super crucial. But we see here that HTML is the language that is transferred across our hypertext transfer protocol, right? HTML stands for hypertext markup language. So HTTP, hypertext transfer protocol, is the protocol that transfers the hypertext, the HTML. And so that's why we want to take anything that's interpreted on our server that's not HTML, CSS, or plain JavaScript into something that is HTML so it can get transferred across HTTP. Right? There are other services that are in our TCP/IP heading, right, for transfer protocols across the internet. For example, things like FTP, File Transfer Protocol. Right? Just a bunch of different protocols. However, again, for our purposes, this is the most important one because this is the one that uses HTML as its communication mechanism. So let's just break this down. Right? And we see 1, 2, 3, 4, 5 steps here. And so these are the 5 steps that occur when you enter a URL into your browser. So these kind of things, this kind of sounds familiar to something I've heard of before. I've heard about before. So this might be the point where we want to really dive into this in terms of what's happening here. Right, so the first thing that happens is we send a request to the DNS server. We'll talk more about that in just a second. And then the DNS translates that domain name to an IP address. Your browser then uses the IP address to send a request to the correct servers. So once the server gets the request, it takes the files and prepares the files that you want, sets them up in HTML, CSS, and JavaScript. So if there's any other languages that are mixed in there, it converts them, it interprets them, and converts them to HTML before it sends them back so your browser can deal with them, and then your browser loads the received files. So that's 5 steps in this process that you could kind of draw out or map out, hint, hint. So the first step that happens is that a request is sent to the DNS. So the URL, which is the Uniform Resource Locator, is sent to make the request. Right? When I fire up my browser, and I go up here to the top and I enter www.clevelandcc.edu, I've entered a domain name into my browser. And so when I hit enter, I'm going to get the website back almost immediately, right? But we got to think about all of the things that are happening in the background while all this stuff is occurring. Right? Because the first thing it's doing is it's saying, well, what's the address of clevelandcc.edu? Like, you gave me the URL, you gave me the Uniform Resource Locator of that, but I don't know where that's at. So I need to ask a DNS server where that item is at. And typically that's going to be your internet service provider that's going to provide that information either through their own DNS server, or they're going to send that request to another DNS server that they trust or that you trust. Right? So your ISP or internet service provider is going to take and make that request to the DNS server and say, okay, well, where is clevelandcc.edu, or where is google.com? So once it gets that information, it's going to tell you, oh yeah, that's at this IP address. Right? So it's going to tell your browser back, this URL is at this IP. So the URL sent to the DNS server by the ISP. The DNS server then looks up the IP address in their big address tables to find out which IP address you need, sends that back to you so you can make the request that you need to that server. So from that point, once you know where the address is at, you can travel there. So your browser uses the IP address to send a request to the correct servers. So it's going to go to espn.com or clevelandcc.edu or whatever website you're going to, and it's going to say, hey, I want what you have. I want you to serve me these files. Right? Hey, kitchen, the person at table 3 wants a steak. Look, can we cook them a steak? Right? So at this point, the files are going to get prepared. Right? The server is going to prepare these files. If it's anything that's not HTML, CSS, or JavaScript, it's going to interpret them using the coding language interpreter that's on the server into HTML, CSS, and JavaScript. And then it's going to take those files and send them across the internet as a packet of information to you, or multiple packets of information, actually. So these packets are flying across the internet, and they get to you, where your browser then unpacks them and parses them and puts them on the screen so you can see them. Right? So again, what you are seeing is a copy of the code files that are parsed. And how these code files are parsed is incredibly important to us. Right? Because our HTML is parsed first. Because, we link to everything else inside of our HTML. HTML is transferred over our hypertext transfer protocol. Right? We have our HTML, our hypertext markup language is transferred over our hypertext transfer protocol. Then our browser starts to read that file that it gets. And it says, okay, well, I can do this, and I can do that, and I can set this up, and I can do that. And then it says, oh, this is a CSS file that I need here. It's telling me I need this CSS file. Let me get that. So it's going to make another request for that CSS file. Get it back and load it up. It's going to make another request for any JavaScript files. Get that back and load it up. Right? So HTML is loaded first. After the HTML loads, it parses the DOM tree structure. And so then CSS files can be parsed. And finally, JavaScript files can be parsed. And this is important to us because when we are building websites, having an understanding of the order in which files are parsed is a big deal, right? The order in which things happen, our order of operations, are crucial sometimes between things working and things not working. So if we kind of go over the entire process up until this point, right, we're making a request. When we put in a URL, or we make a request to a DNS server, we say, where is this address located? It sends us back an IP address. We take that IP address and we make a request to that server. And the server says, okay, let me get you those files that you need ready. It takes anything that's not HTML, CSS, or JavaScript, packages it in something that is HTML, CSS, or JavaScript, sends it back across the internet, where when it finally gets to your browser starts to parse the copy of files that it's been sent. HTML first, CSS second, JavaScript last. And then finally, after all of that, your website's on the page. And one of the interesting things here is that we can actually see this. Right? We can actually see this process. If we look in our browser, we can actually see how everything gets loaded. I'm going to look at Inspect Element here. So I've right-clicked and I'm going to select Inspect Element on our CCC website. And across the top here, we have a lot of different tabs that we can use for different things. If we look at the performance of a website, we can actually see the process sort of occur. So I'm going to record this for just a few seconds here just so we can kind of... So what it's doing now is it's going through this process. It's made a call to the server. It's getting the files back. Any files that it's making, it has to make a call for those as well. So we can stop those and just kind of load the profile here. And we can see what's going on when this is occurring. And we can actually see all this is cached, so it's not as good of an example. But if we look here at our network as well, if we refresh the page there, we can see all these paints happen in real time. Right, we can see how long it took to get some of these files back. And we can see, for example, like if we hover over this green here, it tells us what that green is, waiting for server response. So in that instance, we were waiting on the server to send us that file back. That file in particular is some kind of JavaScript file that we have here. So we were just waiting on that server to send that back to us. But we can see here we have DNS lookup, right? It had to look up the server that hosted it to get the IP address. It had our request has been sent. We were waiting for a response, and then we downloaded that content, right? There are other little teeny tiny steps in here that are more than we kind of want to get into for our purposes. But we can actually see these things occur here, and we can see the times through which they occur. Right, so as we go through here, we can see different ones, and we can look at the higher amounts of time here are going to have more waiting time or more download time. Right. Well, what's amazing out of all of this, right, is that I've been talking a lot about the most basic process of just requesting these files from a server, getting the information back, having it online. We can see all the things that have happened here. But it's just happened within just absolute split seconds, right? Like this here being the longest thing that happened. If we look at our list of items here, occurred in 1.31 seconds. So 1001 and is as long as it took to do the longest thing that occurred here. Now, a lot of this is because, as we can see here, it's in the memory cache, right? If we've downloaded it before, it's in our memory cache, and we can refer to it from there, so we don't have to pull it from the server again, right? So it's cached in our memory on our hard disks. But if we're going to a site for the first time, or if a site has new files on it that we haven't downloaded before, it's doing the entire process there every single time. And it's doing it for every single file. So even though it's doing that entire process every single time for every single file, like everything's just, a lot of things here are, less than half a second, right? 17 milliseconds, 23 milliseconds, 1 millisecond, 2 milliseconds, right? 81 milliseconds for this file. 137 milliseconds, 133 milliseconds. Just within the blink of the eye, all that stuff is occurring. It's a lot of information. It's a lot of data that's being traveled. But it's crucial for us to kind of understand at least a baseline of what's going on so we can better understand how to set things up for our websites. Because understanding order of operations is absolutely crucial. So we'll stop here. That's where we'll stop for today. We've hit our hour. So we will go ahead and stop here. Thank you for watching. I'll hang out in the chat for just a few minutes, just in case anybody who's watching with me live has any questions. If you are watching the recording and you have questions, feel free to email me as you have questions. But that's all that I have for you for today. Thank you for watching, and we'll see you next time.